All right, so as a quick summary for arithmetic sequences, you have a common difference, which means you're adding, or if the number's negative, subtracting the same number to get to your next number. And so we call that common difference D. And so if you have a sequence of terms, A1, A2, A3, and so on, you can get to the next term by adding this common difference D. And so there's what's called a recursive formula, which says you can get to the nth term, any term, by taking the previous term, which would be a n minus 1, and adding whatever D is. Okay, we also have an explicit formula, which says you can get to the nth term by taking your first term and adding n minus 1 times D. Okay, and so we prefer an explicit formula because if we just know the first term, let me get a different color. If we just know the first term and the common difference, we can get to any term without knowing the previous term. For the recursive formula, we have to know the term right before it. And so if I want the 100th term, I would have to have the 99th term to be able to add D to it. So we're not a big fan of the recursive formula. We always prefer the explicit formula. And so I do want to label what all of this means for you. And so for the recursive formula, this means previous term. This is your common difference, which also shows up here. This is your first term. Okay, and so we're going to look at some examples. And so we have this arithmetic sequence: 2, 5, 8, 11, and 14. And so to get from 2 to 5, you have to add 3. Add 3 more to get to 8. Add 3 more to get to 11. Add 3 more to get to 14. And so that makes this sequence arithmetic because there is a common difference. Some people say constant rate or constant difference. Common difference, D, is 3. Okay, so for the recursive formula, we could get the nth term by taking the previous term and adding 3. Okay, and so if I wanted the 100th term, I would have to know the 99th term to be able to add 3 to it. That's the recursive formula. And so to fill in this table below, for the first term, our first term, n, when n is 1, a sub n would be 2. For our second term, we'd have a 5. Our third term, we'd have an 8. Fourth term would be 11. fifth term would be 14. So n is the term number, and this is the actual term. Okay, and so a sub 1 would be 2, a sub 2 would be 5, a sub 3 would be 8. Okay, and so what this table does is it gives us a set of ordered pairs that we can graph. Okay, and so we have the point 1, 2. And then we have the point 2, 5. And then 3, 8. Oh, sorry, I messed up. I was like, that doesn't look right. 1, 2 is right here. There we go. So 1, 2, 2, 5, 3, 8, and we could do 4, 11 up here. And so what kind of function is this? We know that this is a linear function because these points fall on a line if I were to connect it. And so if we were to connect it, we would have a y-intercept. And so to find that y-intercept, we need to figure out the pattern. And so it looks like it's going up 3 over 1, up 3 over 1, up 3 over 1. And so our y-intercept would be -1 if we were to continue by going back 1, down 3. Okay, and so our y-intercept, the value would be -1. And so if we were looking at our sequence, that -1 does not show up on our original sequence. And so I'm going to copy that sequence down over here. We had 2, 5, 8, 11. This was a sub 1. This was a sub 2. This was a sub 3. A sub 4. And so if we go back and put the -1, that would be a sub 0. 0th term. Okay, so it doesn't actually show up in our given sequence, but if we were to continue the pattern and go the opposite way, we could get the 0th term, which would correspond to the y-intercept. Okay, for the slope, we already figured it out. We rise 3, run 1, rise 3, run 1. So for our slope, which is our rise over our run, we rose 3, run 1, which simplifies to 3. And so the slope is 3. What aspect of the sequence corresponds to the slope? And I know some of you are already saying it. Our common difference. Okay, that constant number that we were adding to get to each term corresponds to the slope. The constant rate is the common difference. Oh gosh. Okay, so the 0th term is the y-intercept, and the slope corresponds to the common difference. So now if we're writing an explicit formula, we talked about the explicit formula being a sub 1, take the first term, figure out what n minus 1 is, and multiply it by d. And so for this particular sequence, our first term is a sub 1. or 2. And so we have 2. And the value of D was 3. Okay, I always like to rewrite this number in front of the parentheses. And then when I simplify it, it's easier for me to distribute from the left. So 3 times n is n, 3 times -1 is -3. Now we have some common terms. 2 minus 3 would give us -1. Or if we wanted to put the 3 in first, we would have 3n minus 1. And so our explicit formula would be a sub n equals 3n minus 1. And so how does this formula relate to the graph? If we were writing the equation of this graph, we would need y equals mx plus b, where m is the slope and b is the y-intercept. And so we know that would then be, our slope was 3, our y-intercept was -1. And so the graph has the equation 3x minus 1 using slope-intercept form. And so to see how these relate, they're the exact same equation. Here we're calling the 3 our slope. Here we're calling the 3 our common difference. Here, this -1 is our y-intercept. Here we're calling the -1 our 0th term. And so that's how arithmetic sequences relate to linear equations. They're the same. You just have to find the 0th term and find the slope. And you can write this explicit formula without having to start here. You can skip straight to here. And so I'm going to show you how to do that on the next page. Okay, so we need to write the explicit formula for each sequence and then find the 100th term. Okay, and so first we need to find the slope or the common difference. And so to get from 4 to -3, I would have to subtract 7. And then if I subtract 7 again, that gets me to -10. If I subtract 7 once more, that gives me to -17. Okay, and so the slope or the common difference I'll just use D, is -7. And then the 0th term we have to go back and figure out what -7 would give us 4. And I believe that is 11. Okay, and so to write our explicit formula, a sub n equals -7n plus 11, since the 11 is positive. You could also say a sub n equals 11 minus 7n. Either one of those works. And I always like to double check to make sure that actually works. My 0th term is 11. If I subtract 7, I get to 4, subtract 7, you get to -3. And so you can plug in different values for n to check it out. So if I were to plug in 3, that would give me my 3rd term, And so this is just checking. A sub 3 should be this 10, this negative 10. And by our formula, it works. Okay, so now we need to find the 100th term. And so using our formula, we plug in 100 for n, which gives us negative 700 plus 11. Negative 700 plus 11. Negative 689. Okay. For example B, we are adding 0.5, adding 0.5 again, adding 0.5 again. And so our slope, or our common difference, is 0.5. And then if we go back, what plus 0.5 would give us 5? That would be 4.5. So 0th term, or the y-intercept, would be 4.5. And so for our equation, we have 0.5n, that's our slope, so that's why you need to multiply that by n, plus 4.5. Okay, and then remember, I always like to check, say like the third term. Let's check and see if a sub 3, it should give us this 6 right here. And so we would be multiplying 0.5 times 3 and then adding it to 4.5. 0.5 times 3 is 1.5 plus 4.5 does give us that 6. Now we can use that formula to find the 100th term. Multiply 0.5 times 100 and then add 4.5. Gives us 50 plus 4.5, 54.5. Okay, I'm going to do one more for you guys and leave D and E for you to do on your own and then submit. Okay, so first we need to find the slope, or the common difference. From negative 23 to negative 22, you're coming out of debt, so you're actually adding. Be careful on that. Negatives always throw me off. Oops, I think that's supposed to be negative. Plus 1. Okay, and so we are adding 1 each time, and so what number plus 1 gives us negative 23? Our 0th term would be negative 24. And so our slope, or our common difference, constant rate, is positive 1. And then 0th term, or our y-intercept, is negative 24. And so a sub n equals 1n minus 24. Or you could also just say n minus 24. That's the same. So let's double check our third term. We should get negative 21. And so for our third term, we have to plug in 3 for n and then subtract the 24. 1 times 3 is 3. Subtract 24. you end up with negative 21. It's a good strategy for a multiple choice test. Okay, so for our 100th term, plug in 100 for n. So 1 times 100 minus the 24. 100 minus 24, I believe, is 76. Okay, and so when you're using this method, be very, very careful. Your slope, this negative 7, is the one that gets multiplied by n. Here the common difference was 0.5. That's the one I multiplied by n. Here d was 1. That's the one I multiplied by n. In the 0th term that we had to calculate was our y-intercept. And so that's the number that we tack on at the end. Okay, so I want you to try D and E, and then you'll submit this assignment.